Right now, let's talk about ionic bonding, the kind that happens between metals and nonmetals. So first of all, what's an ion? An ion is an atom that has a net charge. In other words, where the atom has gained some electrons or lost some electrons. We're never going to discuss any atoms gaining or losing protons. That is like splitting the atom, all right? So does it happen? Very, very rarely under very special conditions. But for us, we're always going to talk about the number of electrons in an atom changing when it forms an ion. So ionic compounds are attracted ions of opposite charges. So opposites attract. So cations are positive ions, and anions are negative ions. So if we form some positive ions and some negative ions through the transfer of electrons, the positives and negatives are going to be attracted to one another. And that's what ionic bonding is. So let's talk about these two types of ions. So cations are the positively charged ions, which means that those atoms have lost some electrons, right? They've given away some electrons. That way the atom now has more protons than it does electrons. So here is an example. Sodium, the atom, has the electron configuration 1s2, 2s2, 2p6, 3s1. So it has one electron in its outer shell. Now, once sodium reacts to make an ionic compound, it loses exactly one electron. And the reason why it does that is because after it loses that one electron, it ends up with the exact same electron configuration as neon. So by losing that one electron, now it has a full outer shell of 8 electrons instead. And because of that, sodium, when it forms an ion, always has a +1 charge. Note that sodium is in the group 1 elements. It turns out that all of those metals in group 1, when they form ions, all make +1 ions. We'll come back to that. Now, what about some other kinds of cations? Here's magnesium. So magnesium is right next door to sodium on the periodic table. It has 2 electrons in its outer shell, which you guys should realize if you finished all of the viewing for chapter 2 at this point. So when it loses those 2 electrons in its outer shell, what's left over is that exact same electron configuration that neon has. In other words, it now has a full outer shell of 8 electrons. So in general, metals lose electrons until they've lost all of their valence electrons, until they've lost all their outer shell electrons. That's how metals tend to behave when they form ionic compounds. So now let's talk about how nonmetals behave. All right, nonmetals don't lose electrons, they gain electrons when they form ionic compounds. So here's an example of what a typical nonmetal looks like when it forms an ion. So there's chlorine, the atom, over there on the left. It currently has 7 outer shell electrons, 7 valence electrons. If it's going to gain electrons until it has a full outer shell, it needs to gain exactly 1 electron. And by doing that, now it has the exact same full outer shell of electrons as the noble gas argon. So another way to think about the formation of cations, the way metals behave when they form ions, is that metals lose their outer shell electrons to become like a noble gas in terms of their electron configuration. And we can see what nonmetals do now. They gain electrons until they have the same electron configuration as a noble gas. So, to recap, metals like sodium, magnesium, aluminum lose 1 or 2 or 3 electrons until they have a full outer shell of electrons. So because they lose those electrons, the ion that they form is positively charged. And I know that the notes say 1, 2, or 3. I'm just going to go ahead and write in or more, because sometimes metals can lose even up to 8 electrons and end up with a +8 charge as a cation. Nonmetals like chlorine or phosphorus or bromine or sulfur, they tend to form anions, negatively charged ions, because nonmetals gain electrons to have a full outer shell. So, for example, if we were talking about sulfur, if we look at where sulfur is on the periodic table, it has 6 valence electrons. Now, in order for it to have a full outer shell, it would have to gain 2 more electrons, which means that when sulfur makes an ion, its ion would have a -2 charge. Note also that when we write negative or positive charges above atoms, we put the number before the charge. So magnesium is magnesium 2+ when it's an ion, not magnesium +2. So I'm going to go ahead and erase what I just wrote for a second. Oops. So the key concept that we have to use to determine what the charge of a metal or a nonmetal in an ionic compound is this thing called the octet rule. And what it tells us is that any main group element is going to be very stable when it has an octet of electrons, 8 electrons in its outer shell. So metals tend to lose electrons until they have a full outer shell of 8. Nonmetals gain electrons until they have a full outer shell of 8. The only exception to that is hydrogen, which can have a full outer shell if it gains just 1 electron. All right, if it gains 1 electron, then it has a full outer shell because the first shell of electrons only holds 2 electrons. So in general, if we're looking at how many outer shell electrons an atom will have once it becomes an ion, then you're looking for 8 electrons in its outer shell. So nonmetals gain electrons until they have 8 in their outer shell, and metals lose their outer shell electrons, so what's left over is a full outer shell of 8 electrons. Now, if that's a little bit confusing, it's really, really easy for us with the main group elements to remember what the charge of their ions is, because all the metals have the same charge as their group numbers. All right, so for metals in group 1, like sodium, or group 2, like calcium or strontium, or group 3, like aluminum, their group number is exactly the same as the charge on their cation. And then for nonmetals, remember nonmetals gain electrons to form anions, 8 minus their group number ends up being their charge in ionic compounds. So let's take a look at that. So a metal in group 1 is going to have 1 valence electron, which means that when it forms an ion, it's going to lose 1 electron and have a +1 charge. That's why we're saying metal plus. A group 2 metal has 2 valence electrons. When it loses those, it's going to have a +2 charge. A group 3 metal has 3 valence electrons. When it loses those, it has a +3 charge. So if we're looking for examples of each of those, here are the group 1 metals, all of which have exactly a +1 charge as ions. Here are the group 2 metals, all of those have a +2 charge when they form ions. And then the group 3 metals, all of those have a +3 charge when they form ions. Now let's talk about nonmetals. Remember, nonmetals gain electrons until they have a full outer shell. So how many electrons do they gain? Well, let's think of it first this mathematical way, where if we take the group number of the nonmetal, 8 minus that group number will be the charge that that nonmetal has when it forms an ion. So a group 6 element has 6 valence electrons, which means it has to gain 2 electrons because its charge is going to be 8 minus its group number. So its charge will be -2. Actually, a better way to say this than 8 minus the group number would be the group number minus 8, because then we'd have the correct sign as well. So the group number 6 minus 8 gives us the charge of -2, which is what the group 6 elements' charges are. The group 7 elements have 7 valence electrons, so 7 minus the group number, the group number minus 8, so 7 minus 8, gives us the charge of all of those nonmetals in group 7. So all those group 7 elements have a -1 charge. They need to gain exactly 1 electron to have a full octet of electrons. Now remember what your groups tell you. So if you look at the periodic table, the group 6 nonmetals are oxygen, sulfur, and selenium to start. We don't really use the elements further down than that very often. And then the group 7, the halogens, fluorine, chlorine, bromine, and iodine are the common members of group 7. So here is a little modified periodic table that shows you what the charges of the metals and nonmetals in the main group are. Remember that for the metals, it's super easy because the group number 1 corresponds to the charge plus 1. The group number 2 corresponds to the charge plus 2. And group number of 3 corresponds to the charge plus 3. So metals are easy. And then nonmetals, if we do the group number minus 8, that gives us the charge. So for a group 5 element, like nitrogen, 5 minus 8 is equal to -3, its charge. So group numbers minus 8 give us the charge for nonmetals. Another way to think about this is we know that nonmetals gain electrons until they have a full outer shell. So for nitrogen, when it forms its ion, it's going to do that by gaining 1, 2, 3 electrons. That's why nitrogen ends up with a -3 charge, is because it has to gain 3 electrons to have the same number of electrons in its outer shell as neon does, its nearest noble gas. If we're looking at a group 6 element like sulfur, it would have to gain 1, 2 electrons to have the same electron configuration as argon, its closest noble gas. So that's why the group 6 elements have -2 charges. They have to gain 2 electrons to have a full octet. And then the group 7 elements like iodine have to gain just 1 electron to have a full outer shell of electrons. So if iodine gains 1 electron, it ends up with the same electron configuration as xenon, its nearest noble gas. Now, metals that aren't in the main group, and even a couple of really big metals that are in the main group, tin and lead, can sometimes have more than one possible charge. So when we start to write formulas using those metal ions, we'll have to do some special things, all right? So just to let you know, even though we know for the main group elements in group 1 and 2 and 3, most of those main group metals, their charges are the same as their group number. But for the transition metals and for even some of the really heavy main group metals, that's not always true. Some metals can have more than one possible charge. So we're going to have to take that into account when we go to name them. Now, really quickly, since some of you are in learning community class with Bio 160 also, let's look at some important metal ions in the body. So calcium ions are found in teeth and bones. Sodium and potassium, the balance between those two is really important to prevent swelling and heart health issues. Hemoglobin has iron 2+ / iron 3+, depending on whether the hemoglobin actually has oxygen bound to it or not. Chloride is a very important chloride's a very important ion in the stomach and also lots of other places. It has lots of roles biologically. And then magnesium and also calcium to some extent are needed for nerve transmission.